My name is Rajesh Gadiyar, and I'm a Vice President in Intel's Data Platforms Group, and I'm the CTO for Intel's networking business. It's an absolute honor and privilege to be presenting at the NASSCOM 2021 Product Conclave. By the way, a very happy new year to all of you. In my presentation today, I'm going to be talking about 5G and how 5G is fueling significant innovation, particularly with the Internet of Things or the IoT services. I'm also going to talk about edge computing and the need for the industry to move towards a cloud-native deployment model with microservices. And hopefully, I will leave you with some good ideas and some tools and software that allow you to create these new services at the edge fueled by 5G. So 2020 was a tough year for all of us. Now, in spite of the COVID pandemic, I'm really proud of how we have responded as an industry and as a technical community. In particular, I'm proud of the progress we have made with the 5G ramp. Intel, of course, as you know, has been a pioneer in 5G. We've been involved in 5G standardization and development for a number of years. At the Korea Winter Olympics in 2018, we had conducted the first 5G field trial. Now, since then, we have participated in over 100 field trials around the globe. In 2020, we have seen many commercial 5G deployments by global telco operators. Most of the 5G services today are focused on mobile broadband. By 2024, we expect nearly 2 billion mobile broadband subscriptions. However, as all of us know, 5G is a lot more than just mobile broadband. 5G provides massive device-to-device communications. 5G will also fuel a tremendous growth for IoT solutions. By end of the decade, we expect 500 billion connected devices. Think about it. That is more than 7 devices for every person on Earth. 5G also provides ultra-reliable low-latency communications, which opens up the possibility for several new services. Overall, 5G is transforming our lives and delivering significant economic value. Now, in the last few years, we have already seen a lot of innovation in the IoT space, whether it is agriculture monitoring systems for farming or enhancing public safety via real-time surveillance or massive AI-driven industrial automation. The innovations in new IoT applications are changing the way we live and the way we work. 5G is proving to be a great catalyst for the next phase of innovations in IoT applications and services. 5G wireless, with its 10 to 100 times more bandwidth as compared to LTE, 10 times lower latency, end-to-end quality of service with the network slicing technology, and the opportunities in private wireless, 5G is truly becoming a game changer and is fueling a tremendous growth in reimagining IoT services. So I'm super excited about this next phase of innovation. With the ramp in 5G deployments and the immense potential of using 5G to fuel new services, a new area that is fast emerging is the edge. In many ways, edge is the epicenter of new services innovation. So what is edge computing? Let's answer that question first. To me, edge is really about bringing cloud computing closer to the end user. It is bringing cloud computing to where the application is and where the data resides. The new and innovative applications of this modern era are going to require low latency, predictability, data security, and quality of service. Any transaction that goes to a cloud data center can incur hundreds of milliseconds of latency. What this means is that the computing has to be brought closer to where the application is or the service. This, to me, is the essence of edge computing. Now, to give you a data point, today, less than 10% of data is processed outside of a traditional data center or cloud. In the next 5 years, 75% of the data will be created and processed outside of the traditional data centers. This is why distributed computing at the edge is becoming an important part of the 5G and IoT story. Edge computing is a massive business opportunity for all of us. Just the silicon opportunity alone is about $65 billion by 2024. So I'm really excited about the edge. The innovator in me is looking to harness the potential of edge and create new innovative applications that change our lives. Now, so far, we have talked about how computing and communications are coming together like never before in the 5G era to deliver new and innovative services. Now, I talked about edge as an emerging paradigm for delivering the computing needs of these new services. Next, I want to talk about a strong need for us as an industry to embrace cloud native approach for delivering to the true potential of 5G and edge services. The last decade has seen us make significant progress with virtualization, including network virtualization with NFV and SDN. The progress here has been great, and it has created a strong foundation for optimal total cost of ownership with a standard high volume server infrastructure. Now, the next decade is all about the cloud native transition. In the cloud native model, a service consists of smaller microservices that can be deployed anywhere. These microservices are packaged as containers and can be deployed with a high degree of automation at any location. It can be on-premise in an enterprise or a factory. It can be in the network at a 5G base station or a telco central office, or in the regional or hyperscaler cloud. In order for us to bring velocity into the creation and deployment of these new services, it is important to embrace this cloud native model. As you can see in this picture, there are three key tenets of cloud native deployments that are important for us to understand. First, it's platform abstraction. Now, the platform abstraction really allows the components of a service, namely microservices, to be deployed anywhere without any strong platform dependencies. This abstraction is super important because it disaggregates hardware from software and enables cloud scale deployments. Second, it's all about massive automation. We want to be able to automate the process of deploying new applications and services without human intervention. We also want new capabilities and upgrades to be deployed on a real-time basis with a continuous integration, continuous deployment, or what's now known as the CI/CD paradigm. And then last but not the least, composable applications. We want to make applications composable so microservices can be placed anywhere in the infrastructure by leveraging cloud scale and be able to stitch these microservices to deliver an end-to-end service. So the ability to truly compose a service with massive scale. Next, I want to talk about three pillars of Intel's strategy for accelerated innovation with 5G and the edge. First, we have innovated Intel architecture to run high-performance network and wireless-centric workloads on a general-purpose server platform. This is what we call workload convergence. Our vision here is to make a standard Intel CPU a best-in-class platform for running applications and network workloads. We have a full portfolio of products that gives you a lot of choice to run any kind of workload. Second, it's about virtualization of the network. Over the last few years, Intel has collaborated with other industry players to make virtualization pervasive in the network and compute infrastructure. If you take the example of wireless, we see the core network with EPC, the Evolved Packet Core, IMS, and then the 5G UPF, the user plane function, all optimized and running as virtual machines or containers. Now, same is true for the radio access network, where there is transformation underway with virtual RAN deployments. Not only does this deliver significant cost benefits, but it also opens up the platform for automation and deployment of new services. Third, but most important, we at Intel take a lot of pride in our partnerships with the ecosystem. We've always been a strong proponent of a large and vibrant ecosystem. For 5G, IoT, and Edge, we have a strong collaboration in standards community, such as HC and 3GPP, and open source communities, such as the Cloud Native Compute Foundation, CNCF, Linux Foundation, and so on. I think many of you are familiar with our leadership with the Data Plane Development Kit, or DPDK, that changed the face of networking by enabling high throughput networking or on standard server platforms. Similarly, we work with other open source projects such as Kubernetes, the Open Network Automation Platform, or the ONAP, OPNFV, among others. Additionally, we understand the importance of a robust commercial ecosystem. So as such, We have created a program called Network Builders or Intel Network Builders, which over the years has more than 350 participants across OEM, ODM, service providers, and the software vendor communities. Now, in addition to our collaboration with the industry, there are a couple of recent innovations from Intel that I would like to talk about briefly. These are software stacks that provide you the easy button to create cloud-native edge applications and deploy them with velocity. Keeping the need for modular platforms and cloud-native software deployment in mind, we have brought a new tool to the developer community. Let's talk about them. First, SERA, or the Converged Edge Reference Architecture. We recognize that computing today is fundamentally heterogeneous in nature. As an example, an application such as cloud gaming may require a GPU. Content delivery networks may need a media transcoding accelerator. A 5G vRAN deployment, such as a distributed unit or a DU, may need baseband acceleration. SERA provides you a modular platform where you can take a standard server platform and plug in acceleration as needed, depending on the application or service you're looking to build. SERA also provides modular software that complements the modular hardware platform. These hardware and software components are tested and validated as a reference architecture together. So your job in the ecosystem, you can actually take a known good configuration and build any application. Second thing I would like to actually talk about is openness. Openness is open network and edge system software. This is a software platform that enables highly optimized and performant edge platforms to onboard and manage applications and network functions with cloud-like agility across any type of network. It has many pre-built microservices for multi-access edge and has been integrated and deployed in many commercial deployments. It also has built-in connectors for cloud deployments such as Azure Cloud. So this is the easy button that developers have been looking for. So if you've not played with openness, please visit openness.org and download the software and reach out to us if you need any help. In addition to the SERA and openness, for IoT applications such as industrial edge IoT, we have built a software called Edge Insights software that provides you an AI inference solution for the industrial IoT deployments. This software takes time series video data and helps you derive useful insights with edge AI inferencing for applications such as factory automation. Now, you can download all of this software from Intel's Edge Software Hub. There are some reference applications also available at the Edge Software Hub. Let us know what you think after you start using this SDK, and especially if you are having any questions or you run into any challenges. Now, this brings me to the conclusion of my presentation today. In my presentation, I talked about the compelling landscape of 5G, IoT, and edge computing. I also talked about how distributed computing at the edge is becoming an important innovation ground. We also looked at the benefits of cloud-native approach to build new services. I gave you a couple of recent software innovations for the developer community in particular that provide that easy button that you've been looking for building new applications for 5G and for IoT Edge. Now, a brief word looking forward into the future. There are 4 things that I'm really excited about, and I would briefly mention them here. First, terabit networks. We are already deploying servers that can process 800 gigabits per second or higher throughput. Pretty soon, we are entering into the terabits per second era. Now, this will require us to drive more efficiency in how we move and process the data. Self-healing AI-assisted data center. We want our data centers and networks to run like an autonomous vehicle. There's a lot of potential for innovation here, particularly AI-driven closed-loop automation. Proximity computing. We're going to see a massive increase in IoT devices and sensor networks all communicating, talking to each other. As such, efficient computing in the proximity of these devices is going to be super important. And last but not the least, massive automation. I truly believe that we are entering into an era of massive, large-scale automation for everything that we deal with in our lives. We live in really interesting and innovative times. 5G is just beginning to ramp. There is so much more that we will see happen in the next few years. There'll be a tremendous amount of innovation in connectivity. And as a result, there will be a number of new services that will be deployed. I'm super excited, and I hope you all feel the same way. Thank you for the opportunity to present here at this great event. Have a wonderful 2021. Happy New Year.